Okay, so today we'll try to learn about gravitation. We know the basic formula of the gravitation as F equals G m by r square, right? This F equals G m divided by r square is very similar. This is a part of the Newtonian physics, right? Newtonian physics. This is a part of the Newtonian physics. But when I will tell you that in quantum mechanics or something, that that's a nucleus and there is an electron, it has a attraction and it has a repulsion, so that it moves a tangent, right? The formula here is that there's a positive and there's a negative charge over here. So the force will be 1 divided by 4 pi epsilon naught. Let me just wait. 1 divided by 4 pi epsilon naught multiplies q1 q2 r square if the distance between those two is r. The distance between those two is r, so let the formula be this. And I'm not ready to say that in the whole universe is the earth or anything in contact with earth, are they charged? If they are not, then it will be unable to explain Newtonian physics why quantum mechanics is so hard that there's a theory called theory of everything which connects quantum mechanics and Newtonian physics so far, but it doesn't represent that precisely. So the intricate details are missing. So even any part, right? So let's search. Let's search what that. Let's say is are planets charged galaxy, right? Yes, planets in a galaxy, including in our Milky Way, are considered to have a net electric charge, right? This charge is influenced by their environment and interactions, okay? Space surrounding solar wind. So things are okay to explain. So these are charged. Let's say there is a q1 charge and a q2 charge. So q1 charge as attraction as a repulsion. But now these objects doesn't carry a negligible mass. In quantum mechanics, here you see the mass of a nucleus and the mass of an electron. They're so negligible, but in the whole galaxy it is not. So it is proportional, the mass 1 and the mass 2. let's assume that m1 is this and m2 is for this. So f is proportional to m1 and m2, right? Now f is also proportional to, inversely proportional to r, right? So the far it goes, the more distance they do have, the lesser force will be applied on the inferior object. But there's a problem that quantum mechanics doesn't represent this relation. It says that it is inversely proportional to r square, not only r. So the graph, it will not look like this. It's wrong. It will look something like this. Let me just so as you can see here, it is not touched. It looks like it is touched, but it's not touched, and it will continue till infinity and will never match. So that is the graph actually. It is not a graph, it is the actual graph of this, right? Now okay, so from quantum mechanics equation we say that this, right? And then there's a constant, this, which we say 1 divided by 4 pi epsilon naught. Epsilon has its own value, pi has its own value, and 1 divided by 4. Okay, these all things are fine to consider, but the constant here, it depends on something. It depends on what? It depends, see, in quantum mechanics this k depends in the medium, so that by relation, or it's a spontaneous event that automatically in a medium there's a permeability, there's a constant for electricity permeability, right? So it represents the medium. So the constant has a significance in every every branch of physics. This constant has a significance. Either it represents a medium in quantum mechanics, or in Newtonian physics, this k represents something else, and it represents something very interesting, which is called the exchange of particles. Now, what is the exchange of particles? See, or let's say an object, right? Not us. Let's say an object, and the earth, sorry, it has a particle, a specific particle, which shifts, and this object also gives back the same particle, and this exchange of particles. By this exchanges of particles, an event is created, and it creates a force. Let's say due to this event it creates the force, or it the force is a the force is an indirect phenomena. The phenomena, or the let's say resultant, is a result of this phenomena, of this event. So the result, the need at the end of the day, due to the happening of this phenomena, the force gets activated, and it walks. It walks. It walks. How it works? The object is giving, and particular object is at the same time that particular object is being given by the earth to the object. So the exchange of particles, this event results the force, the activation of force, and when it spikes that, the force actually works, and the object stays on the surface with a gravitational acceleration. So this particle, or this element, is called gravity. Due to this element, due to this exchange of element, due to the exchange of this element, the K turns G, and then hence we say that F is equals G mm r square, or G mm r square. The significance, it has a significance. The G is not just like that. It has a very important significance of it, and if this graviton wouldn't have been exchanged, this G wouldn't have been derived. This constant wouldn't have been turned to G, and this G wouldn't have been here. So we got our first equation of the gravitational force. This is the gravitational force, right? Okay. Quantum mechanics is very interesting, and it's very interesting. Quantum mechanics. Let's hear it from the internet, that what is quantum mechanics. Let's see. What is quantum mechanics in simple term? Quantum mechanics is the field of physics that explains how extremely small objects simultaneously have the characteristics of both particles, the tiny pieces of matter and waves, and disturbance or variation, transfer of energy, and whatsoever, right? Lobes, this represents, okay, hydrogen wave function, this represents the lobes, right? Double dumbbell, yeah. So quantum mechanics is fun. Okay, here we know the term electric intensity, right? Electric intensity. The intensity is a form of force which is a form of force and an event which has happened due to having a point charge of 1 coulomb as an object in a field where the central charge is q, and it influences all charges in its radius, in its radar, right? So if there is a point charge 1 coulomb, it influences this also. So then it becomes then it is the event is called the electric intensity. It's a form of force in favor of the central charge. Let's say there is a point object. The world is so big that compared to the world, anything on its surface is a point. In quantum mechanics, there is a central charge q in this electric field, and there is a point charge small q consists of 1 coulomb. So this point charge consists of 1 coulomb charge, and this is the q total. So electric intensity, so if we say that force is equals k multiplies q and q1 q2 r square. So one is, let's assume that q1 is the central charge, and that tiny little object is a 1 coulomb, consists of 1 coulomb, and r square and k, and distance as e. But in galaxy, this consists of mass. In quantum mechanics, these particles are calculated via charge due to they having a very they are consisting of very small mass, like very negligible mass. But in galaxy it's not, it's the very opposite. So let's say this is the earth, and this is the object. It has a negligible mass in respect of earth, but this earth doesn't have a negligible mass, and the mass is 6 multiplied 10 to the power 24 kgs, and that's a lot, right? So okay, let me just okay, so this electric intensity equation will turn into, this k will turn into g, and this q will turn into m, and this r square will remain the r square. This r is also a constant, so it has a specific radius of 6.1 to 10 to the power 10 to the power 6, maybe 6 kilometers if I'm not wrong. Okay, so this is the electric intensity. What about the voltage? In quantum mechanics, a voltage is represented as W divided by Q, means the work to bring 1 coulomb of or Q charge of energy to the electric field. So the voltage is the work done to bring Q charge of energy in the radius or the radar of the electric field. In galaxy, a very important thing is the voltage is the work done to bring a Q charge of a point to the electric field from an infinitive distance. Like a distance is like very far and very far. That this R, let's assume that this is R. So R is very far from the field. So it's infinity, right? It can be considered as infinity. Okay. And whenever this the Ramanujan equation actually taught us that the summation of 1 plus 2 plus 3 plus equals minus 12, if I recall the Ramanujan equation. So how is that possible? Right? Dot n equals minus 1 divided by 12. So how is it possible? Right? It's a question. So no, there is something which makes it negative. This infinity is the main agent which resulted this negative. Actually, when in simple mathematical equations, like in simple mathematics, the numbers works very magically, that 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus dot plus infinity, you would say. Right? So infinity, when you're giving infinity, if you like replacement of infinity, if you keep saying that 34 plus 35 and 36 and you're on and on and on, and you're just writing, you're up to like 1 0 0 0 0 0 0 1, then 1 0 0 0 0 0 0 2 1 0 0, and you are on, right? And you're on 1 crore, 2 crore, 3 crore, and then you are on 100 billion, 101 billion, 102 billion, and you're just continuously adding this up. It will not result in negative 1 by 12, honestly. But when you will write the 1 plus 2 plus 3 plus 4 plus dot plus infinity is equals negative 12, it's right. If you put a summation here and limit this to infinity, you are giving access. This infinity is magical. You're giving the access to the infinity to do anything. Like the number system from 0 to positive things, and the number system to the negative things, right? And this infinity gives a supernatural power to turn the whole number range. It just like, it kind of bends the number range, and it creates an oblique. So the number of the summation of all positive numbers, it's not like to infinity, up to infinity, it also defines the negative all, and then it also defines that positive all. That's why it can be called as the minus 1 divided by 12. Now, why Ramanujan did land on this very random number which has no connection with this minus 1 divided by 12? How is it possible? Ramanujan basically assumed it, actually, and I even don't know why did he assume it, but I don't know the perfect answer for this. But the way I know that this infinity gives us the power to put this negative, because this infinity means both negatively infinitive and both positively infinitive. So when I will say that something from infinity, a point charge, is brought to the field, right? It's brought to the field, and there's a work done. V equals W by 1, right? From infinity. The work equation, actually it represents as Fs, right? And now F, like for if I again switch to the galaxy events, in galaxy, if something is brought from the infinity to the field, like to the earth, right? It's brought to the earth. Let's say it was here and then it was brought to here, or it was here and it repelled and got here, right? It came from infinity to, it landed on it. Sorry, it's not valid. It's not valid. It came from infinity. It landed on the surface of the earth. So the initial was infinity and the final was this surface position. Okay, so if we differentiate this in respect of r, so this s is basically it's r, so yeah, and then it will also be written as, it may also be written as dw plus fdr. Now if we write that dw is f is equal gmm r square, we previously proved that with the help of quantum mechanics. dw is equals gmm, and now if we put an integration sign, so it was from 0 work to it had to do a work of w to bring that object, and then gmm r inverse to dr, so it results in minus gmm divided by 1 divided by r, and as a limit of it came from infinity to, it landed to a radius of r, to the surface. came to the surface. So from the center, the distance is r. So it's infinity to r, and then minus gmm, and this is 1 divided by r. So, and this is w equals gmm divided by r. Now, in quantum mechanics, if let's say if two objects are maintaining an r distance, so it has a potential of gravitational potential energy. It's not for the quantum mechanics, for the galaxies, for the gravitation, but I'm using the example of the quantum mechanics. So in galaxy, the potential, it is the potential. The potential is gravitational potential energy divided by m. So the gravitational potential energy is minus gmm divided by r. So the gravitational potential energy is minus gmm divided by r is m, and this mm are cancelled, and hence you got g minus gm divided by r. It is also written as minus gm divided by v equals minus gm divided by gm. V equals minus gm divided by r. It will also be written as that. Okay, so we got three equations basically for force, for electricity, intensity, and voltage. Now we have to shift from quantum mechanics to gravitation. Totally. Think of an earth. It has a center. It has a radius. There's an object. Our earth isn't that much perfect of a circle. It's that kind of circle, right? So in some point, if there's an object, right, and there's an r distance, then it covers the object and it says that no, it's the r distance, right? But here you can see that it's on the surface, so it's not the earth is not including the object, moreover it's decluding the object. So the objects, the radius of that object and the radius of this object should be combined as both. So there are two different scenarios. One, an object is on the surface, and two, an object is covered or in the favor of the earth. The earth or the earth's radius covers the object's radius. Okay. So if I start with the case 2, that where this r covers the small r of that object, so eventually it becomes r, right? So the force equation should remain the same for that particular object. But for the case 2, it's different. It's r plus h whole square. Now, F equals gmm divided by r square. F equals mg because it gives a it has a weight of mg to the center. It has a centrifugal force, but it has a weight force in favor of her. mg is equals gmm divided by r square. So we cancel this. So g equals gm divided by r square. Also, it's also written as gm